we go. So we're doing the second part of P2. Yeah, we have chapel today. I need to get through these 6 rules. Here we go. Okay, so yesterday we talked about the rules of exponents. Today we're going to talk about the properties of radicals. Yeah. Okay, so there are 6 property of radicals we're going to focus on. Number 1 is this. If I'm taking the nth root of a to the m, what happens? Nth root of a to the m. How can I, do you guys remember this at all? These ones are a little bit. If I'm taking the nth root of a to the m, I'm going to break it down. And what I'm going to do is take the nth root of a first, and then I can raise it to the m power. Okay? So if I have the cube root of 8 squared, I'm going to break it down to take the cube root of 8, and then I'm going to square it. So what is the cube root of 8?
2.
2. And what's 2 squared?
2.
2 squared is 2.
1.
No, 2 squared.
4.
There you go. And then 2 squared is 4. And that would be what you're looking for. That's the first rule, or the first property. The second property says what happens if I'm taking the nth root of a times the nth root of b. What do you think I do? Yeah. You didn't like these last year. What happens if I take the nth root of a times the nth root of b? What do you think I can do first? Or how can I rearrange that? You can do what, Lindsay? Yeah, good. Lindsay says I would multiply a and b first and then take the nth root of that. Okay? So if I have something that says radical 5 times radical 7, the square root of 5 and the square root of 7, I'm going to say, oh, the square root of what's 5 times 7? 35. So I'm going to take the square root of 35, which that's its simplest form right there, basically, so I can leave it at that for now. The third property is what? Yes. The third property is this. What happens if I'm taking the nth root of a over the nth root of b? How would I rewrite that? The nth root of a over the nth root of b.
Something's wrong with your light.
That's okay. Nth root of a over the nth root of b. If on the top one, when we were multiplying them together, we multiplied first and then took the nth root, what do you think you're going to do on this one? Divide first, yes, divide first. So I can divide a by b and then take the nth root. Okay? So let's say that, what can b not be in this case? 0. B cannot equal 0. Okay? So let's say that you have the 4th root of 27 over the 4th root of 9. What I can do first is I can say, okay, I'm going to take the 4th root of 27 divided by 9. What is 27 divided by 9? What? 27 divided by 9.
4.
3. So then I would simply have the 4th root of 3 as my solution. Okay, 3 more. Number 4 says, what happens if I take a radical of a radical? Ooh. I'm taking the m root of the nth root, okay, of a. It's basically like when you have a to the m raised to the n, what do you do there? When you have a power to a power. What do you do when you have a power to a power? You multiply the powers together, yeah. So here I'm going to multiply these radicals together. So So I'm going to take the radical, I'm going to take the m times n radical of a to make it easier. Okay, don't get overwhelmed by that. So if I am taking the cube root of the square root of 10, what I'm actually doing is taking 3 times 2, so I'm taking the 6th root of 10. The 5th one has parentheses this time. What happens, this is actually probably the easiest one. What happens if I'm taking the nth root, okay, of a raised to the nth power? What happens with those? If I have a root raised to the same power. What do you mean the same? It does. This power, this root being raised to this power cancels it and gives me just what's on the inside of there. Makes it super simple, okay? So if they're the same numbers, the same power and the same exponent or the same power and the same root, then it's easy. So if I am taking the square root of 3 squared, okay, these cancel, giving me 3. And then the final property is when I'm dealing with for an even power, or for an even x radical and an odd x radical. Okay, for an even, so there's kind of 2 rules in here. For an even, if I'm taking the nth root of a to the n, okay, I'm taking the absolute value of a. So if I have radical negative 12 squared, okay, I'm taking the absolute value of negative 12 to get my answer. Because I always have to have a positive answer when it's even. If it's odd, okay, and I am taking the nth root of a to the nth power, okay, that means I would get a out. I'm just going to cancel. So, because I can have an odd answer when I have an odd power, but I can only have an even root when I have an even power. So then in this case, if I were to take the cube of negative 12 cubed, okay, I'm going to get negative 12 as my answer. Those are the 6 properties of radicals we have to take a look at today. We'll probably spend a little bit of tomorrow on this as well. So, let's look at some examples. Let's do these. Tell me, what would I do with this? If I have radical 8 times radical 2, how do I solve that? What rule do I use and how do I solve that? You say I'm going to use number 2? Okay, yeah, because they're both the square root of something. So let's go ahead and multiply them together first. So I'm taking the square root of 8 times 2, which is the square root of, which is 4. Good. Okay, what about B? What rule am I going to use? You want to say number 5, because number 5 would be correct. Okay, so rule 5. What do you end up getting when you do that? What? Not radical. The radical cancels out. So this and this cancel out. You get 5. Okay. what about this? Let's do this one to make it a little bit different. The cube root of x cubed. What rule is that? And what do I end up getting?
It's like one
It's like rule one.
or
Nope, not rule one because these are different different letters, different variables. So I have to look. It's 6. Is it even or odd? Is the power even or odd? Odd. So my answer becomes whatever's inside of here. Okay. Good. What if I'm doing this? Cube root of 125 squared. Cube root of 125 squared. Do I have any that look like that?
one.
1. Okay. This was this is rule 1. So what do I need to do with that?
You can put the 2 on the outside.
Okay, I can put the 2 out on the outside and take the cube root of 125 first. What is the cube root of 125?
5.
You said 25? No. But you can put it into, these graphing calculators have the cube root already programmed into it. And then you take it and you get 5 because it is right. And so then I have 5 squared, which is what?
And 25.
Okay? So there's some rules and things that you're going to be doing on your homework like that. You're going to have to identify what is happening. When something says, put in simplest form, what does that mean you're doing? As far as you can go. Reduce as far as you can go. Okay? So let's simplify some of these radicals. Let's do this. Let's take the cube root of 24. Let's simplify. How would I simplify the cube root of 24? Is there a perfect cube of 24? No, no. But what multiplies to give me 24? What can you think of?
3 and 8.
6 and 4. Does 6 or 4 have a perfect cube? 4 doesn't, has a perfect square. What does 3 and 8 do? Okay, 8 has a perfect cube. So we're going to divide this into the cube root of 8 times 3. Okay? And the reason we want to do that is because, like Alex said, 8 has a perfect cube. What is 8's perfect cube? 2. Okay? So then your answer is going to come out to say, whoops, that's not what I want, right? It's going to come out to say 2 the cube root of 3. Okay? The other way you can do this, remember last year we made factor trees? You can do it that way as well. So if I were to take 24 over here and do 8 and do 3 and do 4 and 2 and 2 and 2, I would see that there's 3 of those, so I can take it outside of the radical, and then I leave what's left over inside the radical. Do you remember that? Okay? So there's that. What happens if you want to combine radicals? Okay? Let's say you want to combine. And you have 2 radical 48 to the square root of 48 minus 3 radical 27. 3 the square root of 27. Can I combine those right now the way they are? Do they have the same radical, the same number in the radical? No. So I can't combine them. So I need to get them into the same number. Okay? What can go into 48? 8. What do you get when you divide 48 by 8? You get 6, right? So if I take 48 and divide it by 8, I get 6. Let's keep reducing these. 8 reduces down to what? 2 and 4. 6 reduces down to 3, and 4 reduces to 2 and 2. Here's a group of 2, here's a group of 2. Okay? So 2, this represents 1, 2, this represents 1, 2. 2 times 2 is 4, okay? And then I have to multiply it by the 2 that's already here, so 4 times 2 is 8, and I get 8 radical 3. Okay? 27 breaks down into what? What does 27 break down into? What does
3.
9 and 3? And what does 9 is 3 and 3, right? So there's a group. So 3 times 3 is 9 radical 3. Now I have the same radicals. Now I can subtract. What is 8 radical 3 minus 9 radical 3?
Radical
Probably like negative radical 3 since this one's negative and is larger. But yes, you are correct. Negative radical 3. Good job. Okay. We can also do it for addition. Let's say we have this. Let's say we have 3 radical 8 plus radical 18. What do I need to do to combine these? What do you need to do to combine those? You need to find what?
Oh, the root.
I need to figure out what the radical could be. So once again, factor tree. 4, 2, 2, 2. There's a group. 2 times 3 is 6. Radical 2 is what you have there. Plus, what's 18 break down into? 3 and 6. And 6 breaks down into, and there's a group. So I take the 3 outside of it, and I have 3 radical 2. Now, can I add those together? What do you get when you add 6 radical 2 plus 3 radical 2? 9 radical 2. Good. Okay, that's where we're going to stop today. Tomorrow we're going to talk about rationalizing the denominators and numerators, but today we're just stopping with adding and subtracting.
Like,